Hello guys, my name is Joseph AGK OG. I hope you guys are having a good day. It is really a warm day today, and let me tell you this, I'm enjoying it. I hope you're doing so as well. Today I'm going to introduce you to a type of conditional probability. We call it the Bayes theorem, or some books they use what they call Bayesian theory. Okay, well, in the simplest way to explain Bayes rule is that it is used on occasions that includes, medical testing for rare disease. So in that case, we use it to estimate the probability of actually having that disease, given that the test is positive. Sometimes in other areas of life, like our social life, we can also apply Bayes rule to determine the kind of friendship we do, so that we look at our previous relationship and then use it to determine what kind of relationship we can get involved with based on the outcomes that we experienced in the past. And we can use it to calculate the probability that the coming relationship or our anticipated relationship with somebody will be, beneficial. So we can apply it in a way. So remember, it is a type of conditional probability. The only difference is that now we are giving more information. Okay, now, so Bayes rule, our goal usually is to calculate the probability of A given B. Remember, in a conditional probability, the key word there is given. So A given B, where A is a different event, B is another event. So our interest is to calculate the probability of A given B from the information we have about B given A. So from the previous information we have, in the case I was using a friendship, we can determine okay, if this one will be a fruitful friendship or relationship or not, based on the condition we experienced in the past, or that you will have the disease given that a different condition, and so on and so forth. So in other words, I wrote here, suppose two events have the prior probabilities of A1 and A2, which means that the A1 and A2 are the probabilities that you have that are determined without any other information, because you have it in the past. Anyway, let's see how it works. Here is the Bayes formula. So if we have two events, A1 and A2, suppose they are mutually exclusive. When we say that they are mutually exclusive, we mean that they cannot occur at the same time. Okay. Assume the conditional probabilities, probability of B given A1 and B, the probability of B given A2 are known. Then the probability of A1 given B equals the probability of B given A1 times the probability of A1 divided by, and you repeat it at here, the same thing, you repeat it here, then plus all the possible probabilities that you have based on the information that you already have or that you are given. So you add all of them at the denominator. Meanwhile, the one you're looking for is the numerator includes what you got from here. Okay. Now, this is just a breakdown of the formula. Look at how the actual formula looks. So you at the denominator, you add all the possible A1, A2, A3, all the way to the last prior probabilities. Okay. All right. So that means probability of AI, when I represent all the prior probability for all the number of events given, and B is the event that has already occurred. Okay. All right. Let's see the application of this rule to solving probability problems. Now, some books will have a summation sign here, trying to compress all this into one single formula by using the summation sign. But for my students, I always like to write it this way so that they can know actually what we are doing here. This plus here, that, and another plus mean that it continued until the last number of choice of events, n, which is an. See? Okay? Now, I always say this. The formula in statistics might look like a monster, but when you start using it, you will discover that it is not a monster. It is just a formula. Let's apply it to this question. It says, a book club classifies members as heavy, medium, or light purchasers, and separate mailings are prepared for each of these groups. Overall, 20% of members are heavy purchasers, 30% are medium, and 50% are light. See, these are the prior probabilities already. A member is not classified into a group until 18 months after joining the club, but a test is made of the feasibility of using first 3 months purchases to classify members. See? Now, the following percentages were obtained from existing records of individuals classified as heavy, medium, and light. So this, all the information they have, they give us here. Number of purchases in the first 3 months, those who are heavy, medium, and light. See, these are the conditional probabilities given to us. But this one they said here, he says overall 20% of members are heavy purchasers, 30% are medium, and 50% are light. These are the prior probabilities. Okay, so we can see that we are given more information here than the regular conditional probability. That's why we use this formula of Bayes. Okay, now it says if a member purchases no book in the first 3 months, what is the probability that that member is a light purchaser? So how do you solve this? First of all, let's identify our variables. I use L for light. Now remember, the formula I showed you here, I just formula. You can always substitute any letter or keyword here, depending on your question. So here, I use L to represent AI or A1, and I use M to represent A2, and I use H to represent A3 if it's here. Okay, where L is light purchaser, M is medium, and H is given. And the question already gave us the prior probabilities. Let me refer you back again. It said that 20% of the members are heavy purchasers. That's why we have here heavy, 0.2. It means 20%. Okay, let's go back again. 30% are medium. See, medium, 0.3, which is 30%. All right, let's go back again. And 50% are light. Okay, L 50%. See right here. Good. Now, because now we're gonna use this formula, probability that is the person is a light purchaser, given that he didn't buy any book, that's a 0 purchase, is the probability of 0 given light times the probability of light divided by probability of 0 given light times the probability of light, which means basically repeating this, what is at the top here. But then you have to add other information for the medium purchasers and for the heavy purchasers, okay? So we have the probability of 0 given medium times probability of medium plus probability of heavy, the 0 given heavy purchaser times probability of heavy purchaser, okay? Now it is time to plug in the numbers. Starting from here, 0 given light are here. 0 given light purchaser, which is 60%, which is 0.6. Okay, we put it here, 0.60 times, okay, probability of light. We already told us that in the question that the probability that the person is light purchaser is 0.5. So you've got 0.5 right here times 0.5 divided by, now I repeat the same thing here. This repeated right here. Plus, now you add other information given for heavy purchasers. We have, what is it? Okay, sorry, my mistake. Okay, the probability of 0 given medium purchaser. Okay, look at medium right here. Medium and 0. So 0 given medium is 15%. Okay, all right. 0.15 times the probability of medium. They already told us in the question that medium is 0.3. So you put 0.3 right here. Plus the last one, which is the heavy purchasers. 0 given heavy purchasers is right here. 0 given heavy is 5%. And you can see 5% right there. Times probability of heavy purchasers. Now the question told us already that heavy purchasers are 0.2. So you got 0.2 right here. Now, we multiply all this, you get this answer. Let me show you how to multiply it. You can get this directly from the calculator by, using a simple method. So I usually use a parenthesis, we make it easy. So I have at the top, the numerator, I have my parenthesis opening. I got 0.6 times 0.5, right? So I got 0.60 times 0.50. Then I close the parenthesis. That is for the numerator here. Now for the denominator, I got to put double parenthesis. Okay. So I put divided by, first of all. Then I put double parentheses, okay? And I'm going to put this one here. 0.60 times 0.50. Then I close the parentheses for that. So I'm going to put plus sign here and put this one here. Okay, I'm going to put plus sign right here. Then parentheses. Put 0.15 times 0.30. I got 0.15, okay, times 0.30. I close the parenthesis. I'm gonna put plus and put this one. So I close the parenthesis and put plus. Then another parenthesis. 0.05 times 0.20. Got 0.05 times, okay, 0.20. I close it. Now, because I started with the double parenthesis at the beginning, so I'm gonna close it twice. Okay, I've already put the first parenthesis right here, so I'm gonna put the second one right here. Then I press enter to give me the answer. And I get answer is 0.845, which is what I got here. So this means that you remember that 0.845, like I told you when we write the answer for a probability question. It can be percent or decimal or fraction. This means 84.5%. So we conclude that the probability that the member is a light purchaser if he or she purchased no book in the first 3 months is 0.845 or 84.5%. See, very easy, right? This is how we use Bayes' theorem. Okay. Usually, I tell my students, the more examples you do, the more you become better and better in solving statistics questions or any math question for that matter. So let us try another example. Okay. So it says that PNC Bank classifies its credit card customers into 3 categories by their credit scores. Suppose the bank has the following information about the customers. Customers with credit scores of less than 600 are late with their payment 40% of the time. Customers with credit scores between 600 and 700 are late with their payments 10% of the time. And customers with credit scores of more than 700 are late with their payments 5% of the time. So this result, we'll have it on the table right here. So A1 is customer with less than 600 credit score. A2 are customers with credit score of 600 to 700, and then A3 are customers with more than 700. So these are percentages here. Okay, for that bank, so that means 25% of their customers belong to this group, A1, 45% belong to that group, 30% belong to that group, which we can have it as a probability. 25% is 0.25, 45% is 0.45, and 30% is 0.30. Now, it says calculate the probability that a customer has a credit score of less than 600, given that he or she is late on his or her current payment. Remember, they gave us the prior probabilities already. That 40% of customers that have 600 or less credit score, that customers have had that has 600 or less credit score are late 40% of the time. The other group, 600 to 700, are late 10% of the time. Another group, more than 700, are late only 5% of the time. So these are the prior probabilities. Okay, so I have them listed here. Let B be the customer is late with our current payments. A1 is customer have credit score less than 600. A2, those with credit score credit score of 600 to 700, and A3. So now this is how the formula looks like. We're looking for the probability that the customer had a credit score of less than 600, given that he or she is late with payment, is probability of B given A1 times probability of A1 divided by, you repeat this top right here. Then you add the other information given for the A2 and A3 customers right here. See? Then let us plug the numbers. Now, remember, you can switch this around. What do I mean? If I say probability of B given A1 times probability of A1, you can switch it around and write probability of A1 times probability of B given A1. They all mean the same. I say this because that's what I did here. It's the same method. I just put this one first before I put this one when I was putting the numbers. I repeat, according to the commutative property, A times B equals to B times A. So this time this is the same as this and that. So you can switch them around. Now let's put the numbers. The first one is the probability of A, B given A1 right here. Excuse me. They told us here that they are the customers that have less than 600 credit score are late 40% of the time, right? That's what I'm gonna have here. 40% of the time right here, times probability of A1, which is right here on the table, 25%, 0.25. Then divided by it by right division sign, which is gonna be right here. Okay, you repeat it right there. Same thing right, you wrote here, repeat it right here, and you can see right there. Now, plus, we are going to add the rest of the information given about A2 customers and A3 customers. Probability of B given A2. That means the customer is late, given that is A2, where A2 is customer has credit score between 600 and 700. We are told that that probability here is for between 600 and 700 is 10%. So you can see it right there, 10.10 times the probability of A2, which is given on the table as right here 45%, which is 0.45. Okay, then plus, repeat the same process for the A3. Probability of B given A3, we are told in the equation that for those customers that have more than 700 credit score, they are late 5% of the time. You can see right here, 5% of the time, times the probability of A3 is given as 0.30, which is right here, 0.3. So again, you put it on the calculator the way I showed you in my previous example, and you get this result, which means that there is a 62.5% chance. How do I get this? Because you have 0.625. So you have 62.5% chance that a late payment is from a customer with a credit score of less than 600. Now you can see how we can use the bias theorem in calculating probabilities. I hope you enjoy my lecture, and in my subsequent lectures, or in my next lecture, I'm gonna teach you the counting rules and use it to show you and show you how to calculate probabilities using them. Thank you for listening. Again, my name is Joseph Ejikeoji, and I hope to see you in my next lecture. Please do not forget to subscribe to my channel so that you get notifications about new lectures. Thank you. Bye-bye.